Hi everyone, my name is Mohammed Hisham Hussain. I'm an MSc student studying structural engineering at the University of Manchester. For one of my modules, Advanced Structural Analysis, I've been tasked with coming up with a physical model and then explaining a structural concept. So I have made two models, as you can see over here. Both of them are made from spaghetti and marshmallows. And over here, one of them is a goalpost. And the other one is a structure, which is a building, which consists of one bay and two stories. As you can see over here, on this side there are X bracings. So are there X bracings on this side? Two sides have been left without X bracings, and they will form as a control for the experiment. And what I'm going to demonstrate is the importance of a lateral stability system. So over here, the X braces are going to be used as a lateral stability system. You can also have base isolation systems. You can use a shear wall. You can use fixed connections, or you can even use a tuned mass damper. These are all the systems that are used to resist lateral loads on structures. Lateral loads on structures are mainly of two types. One is wind loads, the other one are seismic loads, which come from earthquakes. So what we're going to do is we're going to use this commercial everyday use hair dryer, which is going to act as a wind load on both of these structures, and we're going to see how they're going to deform without the X bracings and with the X bracings. So as you can see, this side does not have X bracings on it. You can see this side does have X bracings on it. So over here we have our goalpost. We've removed the front of the hairdryer now because we need a stronger wind load to take this down. Now we've added our X brace over here. The reason why the structures were not deforming when an X brace was used is because when the wind load was being applied from that side, the diagonal member was tending to stretch. And as you know, these elements are very good when it comes to their tensile capacity. They're good in tension, they're good at when they are being stretched, they're good at resisting those tensile forces. As you can see, I'm trying my best to pull it apart, but it's not breaking. I might not be strong enough, but you can try this at home. But if you were to bend it slightly, I'm pulling it apart, but I bend it slightly. There, it's been broken. But that was not pure tension. There was also bending involved. So then it tends to buckle. And that's what happens when a wind load is applied from the other side. This would tend to, as you can see over here, it's going downwards. It's tending to buckle. And that is because these elements, when they are being pulled apart, there is more material in this direction. Therefore, it's resisting it. When a compressive force is applied, it will tend to buckle like it did just now because there is less material over there and it will give way. So that is the same when you see steel bracings in real structures. You have them in both directions. Over here, we just applied load from one direction, but in reality, you will have them in both directions because you could also have a wind load from the other direction. So thank you for your time. Thank you for watching. For those of you who do not have a background in civil or structural engineering, I hope you learned something new. If you have any questions regarding this video, please leave them down in the comments. Thank you very much.